Right, guys, I thought I'd take this opportunity to do a preemptive feedback lesson. So this will go on YouTube. I'll probably get this done before we even meet up this afternoon. So this is what the task was. It's been uploaded to show my homework. And question 1, this is an AQA piece of classwork, worksheet 1 they called it. Match the following equations with their descriptions. So I've got x squared plus y squared equals 36. And clearly the radius squared is 36, so if we square root 36 we will get 6. So I reckon this equation goes with centre 0, 0. Remember, all these circle equations are centred at the origin, and that'll have a radius of 6. And just check from my other homework. Yeah, I've sort of done that. The other one, if I just go by my homework sheet here, x squared plus y squared equals 625. If you square root 625, you will get a radius of 25. So the centre is 0, 0, radius 25. For this one, x squared plus y squared equals 81. Well, the radius squared is 81, which makes the radius 9. Again, centred on 0, 0. Question 4, well, I've called it question 4 anyway. It's the fourth one down the list, I guess. Have a quick look at that. Yeah, fourth one down the list. So x squared plus y squared equals 6. Be careful, don't go squaring the 6 to make 36. The 6 is already the radius squared. So the radius must be whatever the square root of 6 is, and leave it like that in cert form. The fifth one along is as follows. 2x squared plus 2y squared equals 50. Dividing through by 2, x squared plus y squared equals 25. So the radius squared is 25, and the square root of 25 gives us the radius of 5. Question 6 is plonked over here for some reason. Let's look at it. Why? So I've got this awful little arrangement here, but be careful, it's not difficult. You bring your minus x squared over and plus. You bring your minus y squared over and plus and get that. And so we can see quite clearly that x squared plus y squared is 64. So the radius squared is 64, making the radius of 8. And I think we've done the first question. Let's look at the second one. Draw accurate circles to match these equations. Okay, I bet I didn't do that accurately. Well, no, I did not. But if x squared plus y squared is 36, then the radius squared must be 6. So you open out your compass to 6 centimetres and just swish round. What we should do is always label the key points of intersection as the circle tracks round and cuts through the axes. So we've got 6, 0, 0, 6, minus 6, 0, and 0, minus 6 just there. And the other one, well, that's that. So x squared plus y squared equals 7. I mean, okay, the square root of 7 is a third. So if you're going to actually try and draw it accurately, you need to ask your Casio what the square root of 7 is in order for you to open up your compass and to try and draw a nice accurate circle. Either way, it will look something like this. I mean, obviously be a circle, done better than that, but that'll be the point root 7, 0. And that'll be the point minus root 7, 0, etc. 0, root 7, 0, minus root 7. And whatever your root 7 is, 2 point whatever, and that's what you've got to try and plot. But plotting the whatevers is a bit difficult, but it doesn't matter. Doesn't matter. Let's look at the third question. Alright, so question 3. A circle has equation as seen there, x squared plus y squared is 49. What is the diameter of the circle? What is the area of the circle? What is the circumference of the circle? And let's just do that quickly. So here is the equation of the circle. X squared plus y squared is 49, which means the radius squared is 49. Hence the radius must be the square root of 49, which is 7. Which means the diameter has got to be 2 lots of 7, 14. They wanted the area in terms of pi. This is clearly meant to be non-calculator work. Well, you remember from year 9 and year 8 that area of a circle is pi times radius squared, or pi r squared. Well, so that's pi times 7 squared. That gives us 49 pi. Please don't write down pi 49. That'll be wrong. It's backwards. It's like calling 2x x2. You'll never get that right. That won't be acceptable. And then we've got to work out the circumference. Well, the circumference is pi times d, or 2 pi r. But using diameter, we can just use the 14 from previously in part A of question 3. So pi times d is pi times 14. Written around the correct way, 14 pi. Let's look at question 4. The point 2, 3 lies on that circle. Find the equation of the circle and find its diameter. Okay, let's just do that. Question 4. Okay, I don't know why it's in a different colour this one, but anyway. Here I go. So here I have the points A called 2, 3, and it's sitting somewhere on the circle. So I know the general equation of the circle is x squared plus y squared is radius squared. Plug in the 2 for the x and the 3 from the y. That will give us 13. And so the radius squared is 13. So the equation of the actual circle is x squared plus y squared is whatever the radius squared is, which is 13. There it is. And they say find the diameter. Yeah, find its diameter. Well, okay. We know that if you square root the 13, you find the radius. Yeah, is that all right? Because radius squared is 13, so the radius is root 13, and the diameter will be twice as big as that. So it'll be 2 root 13. And you can leave it like that in surd form, or you can grab your calculator and work out what 2 times square root of 13 equals, and just give it to 1 or 2 dp if you want. Let's look at question 5. First the serious ones. Here's question 5. Okay, so I've got a circle and I've got the tangent, it says so, and it's the tangent touches the circle at the point 5 minus 3. If you can imagine a nice little grid down there, like so, then 0, 0 will be about there. So, you know, this 5 minus 3 doesn't look to scale, but it doesn't matter, just be careful. So there's 0, 0 there, you go 5 across, 3 down, and you're touching that point, and there's the tangent that touches the circle at that point. Anyway, find the equation of AB. All right, let's go for it. Find the equation of what? AB, yeah, the tangent, cool, let's do it. So here's question 5. So this is me drawing a crude picture. Very, very crude. So here's my big circle. I've introduced my grid, so it looks right, and this is my tangent touching the point 5 along 3 down. So I've set up the usual things we've been doing in class, plus also the usual things that you've been doing in previous Zoom lessons. So, and that's my radius cutting right the way through my circle, and there's the radius from the center to the tangent at that point. So I've got to work out the equation of AB, which is that line across there. So the gradient of the radius will be, so imagine that a little bit there. You can see it's going to be a negative gradient. It will be 3 over 5, but it's negative, it's minus, yeah? So it'll be minus 3 over 5, and there it is, minus 3/5. So the equation, the gradient of the tangent will be this one flipped and made negative. So it'll be minus 5 over 3, which is 5/3, or 1 2/3. So the equation of that tangent is y equals 5/3 of x plus intercept. Let's get the intercept, and we know this equation passes through point 5 minus 3. We've got to use 5 minus 3, I'm afraid. So plug in the minus 3 for the y, plug in the 5 for the x. That comes to 25 over 3, which comes to 8 1/3. Yeah, 8 and 1 left over. Take over the 8 1/3 and subtract. So the intercept is 0 minus 11 1/3. Put it all together, and here she is. Y equals 1 2/3 of an x, take away 11 1/3. Very, very ugly, I agree. But it's correct, and you can all do that. What's number 6? The plot thickens. Okay, this one is probably going to look quite ridiculous. This is why I wanted some of you, well, all of you really, to try that question 9 we did during the Zoom lesson, last week. Because if you can do question 9, and I also posted the video up as well, and obviously you can get a screenshot of that. That's what this is about. So really, AQA can set you one of these. It's a big deal. It's a very big deal. It is a big grade 9, this. So they've drawn us a circle. Thank you very much, it helps. And they've given us his equation of the circle. They've drawn in the line 3y plus x equals 5, which is that one. It's not been rearranged in the form of y equals mx plus c, but that's what we're given. That's what we've got to work with. And we know that this circle intersects that line, and that line intersects that circle at the point P and the point Q. And listen to the teaching. We've got to find the point P and Q, which is common to the straight line, and they're also common to the circle, which means in a hidden sort of way you've got to solve that pair of simultaneous equations. You've got to somehow merge this equation with that equation such that you either eliminate the y's or eliminate the x's. So you just get one equation with either x or y in it, but not both. All right? And then once you've got the points P and the point Q, you can work out the length of P to Q by using Pythagoras. So if you imagine you've got a triangle here coming down. There it is. There's your right angle triangle. I'm not going to draw it in. There it is. There it is. Okay. There it is. Right angle triangle. You can do the maths on that and just do this side squared plus that side squared and then square root it. But let's see how it goes. It's a big question. And here's my working on that. All right, so it says on the board. So on the board means I did it as a separate document because I couldn't fit it here. So that's going to be that one, I think. Yeah, question 6. And here it is on the board. Yeah, it's on our Mimeo board at school, but I've got it as a separate document, screenshot, put into Word. So listen carefully now, this is really tough. I have got x squared plus y squared equals 5. That's the circle. I've got 3y plus x equals 5. That is the straight line that cuts through the circle. I have to say, even though they drew us a picture, it's so out of scale that the points P and Q are really not in the correct place at all, and you'll see that once we calculate why they're so in the wrong place and therefore extremely unhelpful. So, okay, I want to eliminate the x's. How do I do that? Well, I'll say x equals 5, take away 3y, and where there's an x squared, you plug in 5 minus 3y, so that we end up with an equation that looks like this, with no x's. Now you can of course arrange it to get y equals, but hey, 5 minus x divided by 3, that's sounding really awkward. It's better just to keep it like that, with no division there at all. So you've got to be able to expand this in your head. So if you can't see that in your head, then do a 5 minus 3y times 5 minus 3y, and then get that bit first. Anyway, if you multiply out correctly, you will get this. And that y squared is that one over there. This minus 5 comes from the 5 here. I brought it over and minused it because I know I'm going to end up with a quadratic equation. Okay, so all this part here is the this part here is the expansion of that, expanded and simplified in one step. And there's your y squared, and there's your minus 5 from here. Yeah. What have I got here? So I've got 9y squared. Y squared is 10y squared minus 30y plus 20. Where does that come from? Well, it's 25. Take away 5 is 20. As you can see, that can be readily factored out with 10. So if you divide everything by 10, you end up with this really baby grade 5 quadratics. Oh, but grade 9 thinking is required to get to this baby grade 5 quadratic. And then you just factorize it as follows. Okay, y minus 2 with y minus 1. It works. Multiply it and see. So if y minus 2 equals 0, y must be 2. What about the corresponding x value? Well, if you put 2 in there, what do we see? 5 take away 3 lots of 2, which is 5 take away 6, which is minus 1. Here, this part, y minus 1 equals 0, take it over and add. Y equals 1. Take your 1, plug it in there, what do you see? 5 take away 3 ones, which is 5 take away 3, which is 2. So when y equals 2, x equals minus 1. When y equals 1, x equals 2. So now we've got 2 points to plot. We've got minus 1, 2. Now look how unhelpful the AQA diagram actually was. We've got minus 1, 2. So minus 1, 2 will be somewhere up here. Is that okay? Certainly to the left of the origin. So minus 1 and 2. It's not to scale, but it's way better than their diagram. And here we've got 2, 1. Well, 2 across, 1 up. Yeah? So I've made my 2 look twice as big as my minus 1, and I've made my 1 up look half the size of my 2 up. So I've actually got a triangle that looks like that. So that's your point P, that's your point Q. I can't remember which way around it goes, honestly. I reckon that's P and Q, but it doesn't matter. That's the correct positioning. And that is the true line of the true position of this line. 3y plus x equals 5. It's got a negative gradient. So, okay, so how big is that part there? Well, I'm going from 1 up to 2 up. Do you see? So from 1 to 2, I've got a jump of 1 unit. And what about across here? Why is it 3? Well, I'm starting from minus 1 and going up to 2. So I've got a triangle with a short side of 1 and another short side of 3, the two shortest sides. Well, now it's baby Pythagoras. So it's 1 squared plus 3 squared, get the answer, which is 10, and then square root it. Leave it like that. PQ is the square root of 10, all right? Leave it like that. Or if it's a calculator paper, then press the square root button. That's how it goes. So that's question 6, and that was a mission. I hope question 7 isn't as tough as that. I've no idea. Let's take a look. Draw a sketch of this. Show that 3 minus 5 lies on the circle. And show that y equals 0.6 of an x, take away 0.68, is actually the equation of the tangent to the circle. Well, that's easier than question 6. It's just show that that's on the circle and then work out the equation of the tangent. And by the way, here's the answer you should get. So when you see a show that, don't get worried about it. They're giving you the answer ready to go. So let's just do it. Where are you? Come here. Right, back to this. So on the board was done. So does it lie on the line? Well, we're given the point 3 minus 5. Well, 3 squared is 9. Minus 5 squared is positive 25. 9 plus 25 comes to 34. So it's on the line. So these two coordinates, when plugged into this equation of that circle, does come to 34. So that point belongs. Done. Again, this is going to be easy compared to question 6. Yeah, I've shown it all right. So what have we got? I've got the point 3 minus 5. So 3 along, 5 down. Is that okay? 3 along, 5 down. There's 3 minus 5. There's my radius. There's my tangent. So the gradient of the radius is going to be 5 units divided by 3. Remember, difference in y over difference in x. But of course it's negative because that is a negative gradient. So I've got minus 5/3. Flip it to get the tangent of the gradient of the tangent, which is that one, which is clearly positive. It's going in a positive direction. So flip it and put minus in front of it. So we've got 3/5. The equation of the tangent is y equals 3/5 of an x plus some sort of intercept. I'm not sure where that's going to go, but we'll see. That's the bit we're about to work out just there. So plug in the y, which is minus 5, plug in the x, which is 3, and just do some raw mathematics. We've got 9/5, which is 1 4/5. Take it over and subtract, which gives us minus 6 4/5. So what's the equation? Y equals 3/5 of an x, because that's the gradient from before, minus 6 4/5. Fantastic. Now I'm supposed to show, that the equation is 0.6x minus 0.68, blah, blah, blah. Well, have I shown it? Yes, I have, because 3/5 is 0.6 and 6 4/5 is 6.8. 4 over 5, of course, being 8 over 10, hence 6.8, and it's minus 6.8. Last question. This is getting tough. Now what? I've got a circle and I'm intersecting that line at 2 points. First find the 2 points. Oh, that's another simultaneous equation. And by the way, it won't work out perfectly. They say give your answer to 1 dp. Oh, and once you've got that, work out the actual length of the line C to D, which feels like another Pythagoras to me. All right, so this is exactly like question 6, but they didn't draw us a picture. Not that that was desperately helpful. Thank you, AQA. So here's the last question then, I think. Yeah, that's the last question. So I can go straight onto this, can't I? Right, hope it's not too messy. Yep, I've made a mistake. And then I started again. Right, I've got this circle and that line. This is relatively easy because I can see that y squared will be this term, x plus 1, squared. So it's quite easy to slide that straight into there and get this, and the y's have gone. So if you now multiply this out, that will give you x squared plus 2x plus 1. I brought my 15 over and subtracted to get minus 14, because 1 take away 15 is minus 14. I divided everything by 2, and it looks like I've got a very easy grade 5 quadratic. The thing is, I can't factorise it out, and besides, the question did indicate give your answer to 1 decimal place, which means you definitely can't factorise it. So I tried to factorise it just to see if I can do it. I couldn't do it. Then I reverted to the formula. All right, so it's going to be minus b plus or minus square root of b squared minus 4ac all over 2a. So that's the formula which you should revise. And so the a is 1, the b is 1, and the c is minus 7. So plug it in carefully, like I've done there, and you'll get 2 answers. You get x equals 2.2 and x equals minus 3.2. So how do you get the y's, sir? Oh, straightforward. If you know that y equals x plus 1, you put each of the x's in there to work out their y's just by adding 1. So there it is. So if you add 1 to that, you get that. If you add 1 to that, you get minus 2.2. So these are my 2 coordinates, 2.2, 3.2. That's for this little set, and minus 3.2, minus 2.2. That's for this little set. Okay, I'm on grade 9 already. Now what's it want? Yeah, like I said, Pythagoras. And that will be the tangent. I didn't draw in the circle. I just tried to draw a little right angled triangle that sort of matches the crude positioning of the C and the D. So if that's 0, 0, that's 2.2, 3.2. And if that's 0, 0, that does look like minus 3.2, minus 2.2. So it looks right from the picture. It makes sense, the position of C and D. Draw a straight line, draw a nice little triangle like so, make it right angled, because it's Pythagoras we're talking about. And how long is it from there to there? Very simple. I'm going from minus 3.2 all the way to 2.2 here. So that's a jump of 5.4 units. So that's 5.4. And how do you get from minus 2.2 on the y up to 3.2 on the y to there? Answer, that's another jump of 5.4 units. Now we do Pythagoras. You square the short side, you square the other short side, which happens to be the same length. Add them together and hit the square root button in one step. So to 1 decimal place, the length of line C to D, or D to C, is 7.6 units. And that, my friends, is how you get grade 9 in this topic. It can't get more awkward than that. To solve a simultaneous equation involving a circle and a straight line, get the 2 points, do a Pythagoras, and get the length of that chord. In fact, CD is a chord, isn't it? So I think it's a chord. Let's see what they've done. Yeah, they're points on the circle itself. So CD forms a straight line, otherwise known as a chord. So I'll leave you with that ugly little picture. I'll sign off and I'll see you sometime tonight. No, this afternoon.